Mohamad.
Thank you. Hello everyone, my name is Mahir. I am a PhD student at Northumbria University under the supervision of Professor Mohamad Kassem and David Greenwood. In addition, Jenny helped me finalize this paper.
Can you please put the microphone?
Sorry.
Thank you very much.
Yeah, hopefully now it is working. So my presentation is about the applicability of blockchain to contract administration in construction projects. I will start my presentation with a brief introduction on construction contracts and blockchain. Then I will move to the point of departure and our results and the identified challenges. Before concluding the presentation, I will present the next steps of my PhD research. So contract administration is a key process in any construction project because this process ensures the protection of rights and the fulfillment of obligations of contracting parties. This process performs various functions at the organizational level as well as at the project level. There exists various standard forms of contract in the industry, such as NEC and FIDIC. According to recent reports published by Arcadis and HKA, as well as to research in academia, poor contract administration is one of the biggest challenges facing our industry. The causes include misapplication of contractual provisions, refusal to execute these provisions, in addition to miscommunication, unclear roles and responsibilities of team members appointed by the employer and the contractor, inaccurate documents, as well as corruption. Blockchain has emerged in the construction research field as a potential solution to tackle common challenges in our industry. So blockchain is a distributed ledger technology that operates on three core components. These are cryptography, consensus mechanism, and decentralization. The main unique features are immutability, traceability, and automated verification and execution of business rules. This automation is enabled by what is called smart contracts. So this is the process of the smart contract creation, converting the relevant conditions from the paper-based contract into computable rules, and create the smart contract functions, deploy them to the blockchain, and if predefined conditions are met, the smart contracts execute the rules and the actions. Moving on to the conceptual background. In the existing literature, there are a few review studies on the applicability of blockchain to contract administration. However, these studies viewed the blockchain as applicable to contract administration from a payment perspective, and it was not sufficiently covered. So we are offering a wider view on this. So accordingly, we identified this knowledge gap. On the one hand, there are individual blockchain-based solutions without a link to the contract administration, whereas on the other hand, there is a vision to have a blockchain-enabled contract, which is called a digitally based contract. So accordingly, we formulated this research question, which is how can the state-of-the-art of blockchain-based applications be leveraged to improve contract administration. Accordingly, we adopted a framework to classify the contract administration functions and performed a systematic review of the existing literature. So this simple framework shows that the contract administration serves three functions at the organizational level. These are coordination, control, and adaptation-based functions. Whereas at the project level, the contract administration serves 11 functions, such as the financial management, document and record management function, in addition to claims. So this framework was created based on guidance notes published by RIBA, RICS, and research papers. Moving on to our systematic review process. So using Scopus and ASCE library databases, and by applying specified inclusion and exclusion criteria, we identified 21 studies that were relevant to the purpose of our study. Accordingly, we identified that the most attention or focus in the existing literature has been on the financial management function of the contract administration, followed by document and record, and performance monitoring and reporting function. Whereas the role of a blockchain has not been investigated in 4 functions, such as contract risk, change management, and contract closeout. So going back to the framework I presented earlier, we can see that the financial management function is shining in the middle because most of the focus has been on it, followed by document and record management. Equally important to note here is that these available solutions have not been integrated. In order to have a blockchain-based contract administration system, we need all these solutions to integrate with each other. We have created this figure to demonstrate how the unique features of blockchain can reduce or eliminate the occurrence of causes behind poor contract administration. For example, smart contracts can tackle issues originating from misapplication of contractual provisions and refusal to execute these provisions. Furthermore, immutability can be a solution to, for example, inaccurate documents. Furthermore, the traceability feature can help, for example, tackle the inaccurate documents and records required for claim management. Having said that, the adoption and implementation of a blockchain to improve contract administration will likely face challenges. In our paper, we identified 7 challenges, and here I am presenting only 2 of them. So the first one is converting the contractual logic modeling into smart contract functions. This subclause I have extracted from FIDIC Redbook 2017 edition, and FIDIC is a widely standard form of contract. It is used widely on infrastructure projects. So the challenge I would like to illustrate here is that in the context of FIDIC, each subclause contains cross-referencing to other subclauses. As you can see here, for example, if we would like to propose a blockchain-based payment system for a project that is governed by a FIDIC contract, we need to have all these subclauses and the conditions thereof converted into smart contract functions in order to have the application for payment subclause executed on the blockchain. So the other point I would like to illustrate here, so we need contract experts to work along with a programmer in order to ensure the output of the smart contract will be identical to the contract-based process. Moving on to the second challenge, this is applicable also to blockchain-based payment systems. So this is called cash farming. This is a cash flow management practice widely adopted by main contractors, especially in the Middle East where I used to work. And this practice allows main contractors to use the supply chain's money for a short period of time, and by having prolonged payment terms in the signed agreement with the supply chain. So I have created this figure to illustrate the point further. As you can see here, that the blue curve indicates the cash flow forecast with cash farming, which is always in the positive zone, in the green zone. Whereas the orange curve represents the cash flow forecast without cash farming, which is a negative zone, suggesting that a contractor will need external sources of money to finance the project during this period. So the general practice adopted by many contractors is to have cash farming as a strategy. So the reason I am showing this, if employers insist on using blockchain-based payment systems, contractors may refuse to implement such systems, and they will ask who will finance the project during this negative cash flow period. So one possible solution is that employers will remove the retention provisions. Otherwise, contractors will increase their bids and the prices offered to employers in order to overcome the negative cash flow zone. Moving on to the next steps of my PhD research. So given the initial evidence in the reviewed literature, it might be possible to produce a blockchain-based claim management system for the construction industry. So my plan includes addressing the first challenge I presented, which is contractual logic modeling. Then I will design a blockchain architecture for selected claims, like claims arising from differing site conditions. Then I will have the developed framework evaluated by a focus group. So my concluding remarks are the study highlights the valuable contribution of researchers to improve contract administration by proposing and developing blockchain-based solutions. Also, the study responds to calls for investigating the role of blockchain in enabling a digitally based contract administration. We have found that the current focus tends to be on improving the payment and document management functions of the contract administration. And blockchain unique characteristics of the immutability, traceability, and smart contracts may reduce or eliminate the occurrence of causes behind poor contract administration. And blockchain-based solutions need to be developed with the involvement of contracts policymakers and evaluated by contractors in order to accelerate the adoption. And as I stated earlier, my next step will be developing a blockchain-based claim management system. Thank you very much for your attention, and I look forward to your questions or comments.
Thank you very much. Are there any questions from the audience?